In the previous video, I have discussed few sum of the electrical power. That sum were little bit easier, right? In this video, I am going to explain few critical sum of electrical power, right? So here is the first sum. A water heater has a rating of 4 kVA, 240 volt, right? What is the electrical energy consumed by it in kilowatt hour and second in joule if it is used for 180 minutes? And the second part is find the cost of electricity if the rate is rupees 7 per commercial unit, right? Here I have shown a water heater. It is also called immersion heater. Its rating is 4 kVA and 240 volt. So first of all, I want to clarify about the first thing came here about kVA, right? The full name is kilovolt ampere, right? So first I have to find out the power. Power equal to, that means real power. What is kVA and what is real power and what is reactive power? I want to just explain a little bit here. This is a right angle triangle, right? This is kVA, that means hypotenuse is the kVA and base is the kilowatt and perpendicular is KVAR. kVA reactive, this is kilowatt and this is kVA, and this is the angle phi between real component and reactive component, and the cos phi, the cos of the phi is called the power factor. Okay, in electricity in higher classes you will read about this, right? So if I want to find out the kilowatt, so what I have to find out? We have to find out the cos phi component of kVA, that means kVA into cos phi. And if I want to find the reactive part, that means this is the real part, kilowatt, and kVAR will be kVA into sin phi, because this is the sin phi component, right? But I can write kilowatt, that means power, kilowatt equal to kVA into power factor. As the heater is a resistive component, it is completely a resistive power. That's why whatever electricity will be consumed will all be real power. Real power, that means resistive drop, resistive power. That means the power factor in this case will be 1. Okay, power factor will be 1 here, right? So the kilowatt equal to 4 into 1, that is 4 kilowatt. Okay, now I can calculate the electrical energy in kilowatt hour. How? 180 minute equal to 180 divided by 60, that is 3 hour, right? Okay, therefore electrical energy equal to power into time. Power is 4 kilowatt and time is 3 hour, so it is 12 kilowatt hour. So this is the electrical energy consumed by this water heater, right? In second part it want to know electrical energy consumed in joule, right? We know 1 kilowatt hour equal to 3.6 into 10 to the power 6 joule, right? This I know, and we can also calculate it. How? I have shown in previous video, again I am reproducing it. So we know here the 1 kilowatt hour equal to 3.6 into 10 to the power 6 joule. Therefore 12 kilowatt hour equal to 12 into 3.6 into 10 to the power 6 joule. If I calculate, we will find it 43.2 into 10 to the power 6 joule kilowatt hour. This is the electrical energy consumed in joule, right? The last part, want to know the cost of electrical unit. It means rupees 7 per kilowatt hour. We know 1 unit equal to nothing but 1 kilowatt hour, right? So the total unit consumed is 12 kilowatt hour here in this part, right? This is 1 unit, 12 unit, therefore 84 rupees, right? So I think the only thing in this sum which is critical about that is KVA, by which the student get misled, and the other thing here in this sum is given to mislead the student 240 voltage, because voltage has not been utilized in any of the calculation of the sum. Now I am going to discuss second sum. This is the second sum. The water in an electrical kettle took 5 minutes to reach its boiling point when it is connected to 220 volt supply. How long they have taken if the supply voltage had fallen to 200 volt, right? So this is the electric cable, right? It is connected to a AC main of 220 volts. Now the water inside it reached to its boiling point and it takes 5 minutes, right? The question is that if the voltage, which is 220 volt, would have fallen to 200 volt, right? So what would be the time required in that case, right? The sum look like quite difficult, but I am going to explain this sum in more simple way, right? So we will calculate the electrical energy taken by the electric kettle in the first case, right? Arom, right, given T1 equal to 5 minute, right, and voltage equal to 220 volt. Okay, therefore consumed can be written as V square by R into time. Here in this case 220 square by R into, okay, I am not converting this 5 minute into second or hour, because if I will change it into other unit, then it will not make any difference what I am going to show here. And if you want to convert, you can convert it into second, right? Now in the second case, voltage equal to 200 volt, resistance is same, and time equal to, we have to calculate, right? Therefore energy consumed E2, here this is E1 equal to V2 square by R into T2, right? So V2 is 200 volt, R is same because the electric kettle is same, and T2 I have to calculate. Now as per condition, temperature of the water have to be raised up to 100 degrees centigrade. Okay, yes. That means electrical energy supplied or consumed by the electrical kettle will be same. That means E1 equal to E2. Therefore 220 square by R into 5 equal to 200 square by R into T2. Okay, I think it is clear now. I have not converted this time into second or hour because it will make no difference in this case, right? But you can do. Therefore R get cancelled and T2 equal to 220 by 200 square into 5. As I have not converted the time into second or hour, I have taken minute, therefore the result is minute. Okay, so this is your answer. I think the sum was quite difficult, but I think now it is simple, and if this type of the sum will come in your examination, now you can solve it. Okay, if you have any query about these questions, and if you have also any other question similar type, then you can write in the comment. Okay, it is given in the sum that the voltage supply is 240 volt, that means main supply, and power rating of the lamp is 60 watt, right? Therefore we have to know first the resistance of the lamp. So we know the formula R equal to V square by P. Okay, because we know power equal to V square by R. Therefore 240 square divided by 60, if we calculate this, we will get 960 ohms, right? So the first part of the question is complete here. The resistance is 960 ohms of the lamp. Now we have to calculate why each lamp, if connected in series across a main of 240 volt, will glow with less intensity, right? So here I am illustrating with a circuit diagram. The two lamp as shown here are connected with a main of 240 volt, right? And we know the rating of the lamp are 240 volt 60 watt, and we have calculated the resistance like 960 ohms. Okay, so here what we will calculate first, we will calculate the current flowing through each lamp, right? It's simple. We will sum up the resistance and we will divide the voltage by total resistance, 960 ohms plus 960 ohms, and we will get the total current as 0.125 ampere, right? In first case the current was 0.25 ampere. Here I am showing how we have calculated the current. It is 240 divided by 960, simple, right? If you calculate, we will get the value 0.25 ampere. Okay, so what we notice here, the current I1 equal to 0.25 ampere and I2 is equal to 0.125 ampere. We know the heat generated across an element is proportional to I square RT, as the current is reduced from 25 ampere to 0.125 ampere. Therefore heat generated will get reduced by 1 by 4. Okay, as shown here. Heat generated inside in the second case will reduced by 1/4 because H is proportional to I square, right? H2, here I am showing this one. Therefore in the second case the heat generated will be less by 1/4 amount in comparison to the previous one. That's why the lamp will appear less bright. Okay, I think it is clear now. If you have any query, write in the comment.